So I'm going to give a talk on functional domain model, but kind of from an event-centric perspective and talk about an architectural pattern known as event sourcing. So a little bit about me. So, way back in the 80s, programmed in Lisp, building Lisp systems, compilers, runtimes, garbage collectors, and that kind of thing. Eventually ended up in the Java world, wrote the book POJOs in Action, which was all about Spring and Hibernate, which are two favorite topics at a Scala meetup. Did a cloud computing startup, called Cloud Foundry. Oh, seemed to have jumped ahead. Not very good with a microphone. Anyway, so I did a cloud computing startup called Cloud Foundry, which then got acquired by SpringSource right before SpringSource was acquired by VMware. And now these days, doing some consulting, and I'm actually working on another startup. And if you want to know more about what I'm talking about, there's a whole bunch of links. So got some example code in my GitHub repo. There's also, I created the website microservices.io, which is the beginnings of a pattern language for describing microservices. And right now there's only 3 patterns there, but I actually have 5 more to go in sort of draft form that I plan to publish in the next week. And follow me on Twitter. So the structure of the talk is, why event sourcing? What is it? Why should we care? And then look at a domain model, really simple domain model that was built using an event-sourced approach. So it's funny. For the longest time, for probably like 8+ years, I've always used this money transfer example. The idea is you go to your bank website and you want to transfer money between 2 bank accounts. You pick the from account, the to account, and the amount, and press a button, and the money gets transferred. And for the past 8 years, I always apologize because I've never worked for a bank and I have no idea how it works in practice. But this is my version. So this is actually a version from a slide in 2007. So you got a service, there's a domain model, traditional OO kind of domain model where state and behavior are wrapped up inside a bunch of domain objects. If you were to look at the code, so it's sort of the standard mutable domain model. So you got the account class and so on. All of the entities are persisted to the database using Hibernate. Persisted to a relational database. So it's very traditional. The service that's coordinating the transfer between the 2 accounts is made transactional with Spring. So pretty standard stuff. Now what's interesting is, so that was from 2007, and you could say that was like how you built apps back then. But if we fast forward a few years, the way we build apps has changed quite a bit. So I really like this book, The Art of Scalability. It's all about building scalable engineering teams, scalable architectures, and so on. And in the book, there's a 3-dimensional model of scalability where you've got x-axis scaling that's horizontal duplication. You've got z-axis scaling that's all about partitioning, database sharding, and so on. And then there's y-axis scaling or functional decomposition, which these days goes by the term microservices, which is very fashionable. So we don't really build monolithic apps that talk to a monolithic database anymore. Things are quite different. So you can imagine that if you apply y-axis splits or functional decomposition to the application, it's now a collection of services, each with its own database. And then the database is split up as well. It's functionally decomposed. We might have accounts in one table, money transfers in another. And then we also could actually apply z-axis splits or partitioning or sharding. And so accounts, the 2 accounts in a transfer could actually reside in 2 separate databases based on their primary key. So, 3 entities, potentially 3 different databases, yet we need to sort of have some kind of business transaction that, maintains consistency between all of these different databases. And yet we can't use 2-phase commit anymore. It's sort of gone out of fashion and it doesn't work because of the CAP theorem and so on. And even if we were to pick a more mundane example of like, well, I'm storing product information in MySQL, and then I'm using Elasticsearch to do text search, how do I maintain consistency between those two databases, right? Kind of in real time and so on. And, once again, you can't do two-phase commit. So you sort of have all of these problems with multiple databases and maintaining consistency between them. And a good solution, a good way of solving that problem is to use an event-driven architecture where when a component or a service changes its state, it publishes an event, and then consumers can subscribe to those events and update their own state. So the component, say, that updates MySQL can publish an event saying the product has changed, and then the indexing component can update Elasticsearch. But interestingly, that actually creates another problem. How do we atomically update state and publish events without using two-phase commits? So we've sort of kind of moved the problem along. And that sort of leads you to event sourcing, which is really an event-centric way of designing your business logic and designing your system. And the big idea is for each aggregate, for each key entity in your system, you identify the state-changing events, the domain events, and you actually define explicit event classes. So for an account, it would be account opened, account debited, account credited, and so on. So we kind of just treat domain events as first-class citizens in our domain model. But that's just the beginning. So sort of the big idea with event sourcing is that we no longer just persist the current state of an entity. You can imagine where we have an account table that's got a balance column. We don't do that anymore. And instead what we do is store the sequence of state-changing events for each entity. So for an account, it was opened with a certain balance, then it was credited by a certain amount or debited by a certain amount. So you actually just store all of the state changes for each of your entities. And then if we actually need the current state, we actually just load all of the events and replay them. Later on, you'll see how that's really just doing a left fold over the sequence of events, and that will just reconstruct the current state. And you might be wondering, okay, so what's the big deal? But what has changed is that whereas before you had to update state and publish events, now all we're ever doing is actually just persisting and publishing events, and there's no separate state that has to be sort of part of some transaction. So we're just doing one thing. And it's a lot easier to do that in an atomic fashion. So that's kind of why I sort of ended up in this world of event sourcing, because it solves a number of problems that arise when you're using microservices, when you're using NoSQL databases, and so on. So the way in your system, the way requests get handled, whereas before we sort of load an entity, a request comes in, we load an entity, you modify it, and then you save back the updated state. In an event source system, it's a little different. You actually first load the events, and then you create, in this case, an account. And then you actually replay all of those events to reconstitute the current state of the account. And then you process the command that's derived from the request, and that gives you new events, which you then persist back in the event store. So we're loading events, generating new events, and appending them to the entity's events in the event store. And that's actually done with optimistic locking. So if there had been two concurrent update attempts, only one of them would succeed. And then when it gets really interesting is off the back end, on the other side, you can have subscribers that express interest in certain event types. And then when events get saved into the event store, the subscribers get notified, which can then enable them to update their own entities or update views that they're maintaining. So they could update Elasticsearch and so on. So it's kind of a totally different event-centric way of building your systems. And there's various event store implementations out there. A lot of folks, I mean, there's even some folks in the room who have ended up building their own event stores, right, Alexi? There's one commercial one out there, Get Event Store by Greg Young, who's been advocating event sourcing and CQRS off in the .NET world for a while. And I'm actually building one myself. It sort of grew out of the first startup idea, sort of then got consumed by the actual event-driven platform. So I'd love to talk more with folks about that. Whole bunch of business benefits to event sourcing. You know, number one, you now have a built-in reliable audit log, right? So any update to an entity has to be done via an event. If there's no event, the update didn't happen. And that's quite different than the traditional way of doing auditing, where you just kind of write your business logic and then you kind of add some auditing code on there, which can get out of sync and be forgotten, and so is not very reliable. Another really interesting aspect of it is that it enables temporal queries. Because we've actually stored all of the state changes for an object, you can go back in time and ask an object, what was your current state 5 days ago? So that can be useful in some domains. It also fits in nicely with machine learning because it's generating the stream of events that can be fed into a machine learning predictive analytics engine, which can then sort of help refine the cat pictures that your system shows to the world. And it also preserves the history of everything that's happened in your system. So you can actually go back and when you implement a feature, you can actually implement it in a way as if it had always been part of your system, because you've got all of the past changes to then go and process. So you can kind of more easily and sort of implement unanticipated requirements. And then there's also a whole bunch of technical benefits, right? So kind of solves a whole bunch of data consistency problems in microservice or NoSQL architectures. And then it also eliminates much of the OR mapping problem, right? You know, we've sort of all been struggling with how to map a rich domain model to a flat relational schema. Given that events tend to be simpler in structure, it's fairly trivial to serialize them. Actually, you can guess you see the slides a whole lot better in the dark. You know, there's a bunch of drawbacks, right? You know, it's kind of a weird and unfamiliar way of designing your domain model. Takes a bit of getting used to. And sometimes events can, you know, be a sort of hit, because events never go away once they've been generated. You've sort of got this historical record of all of your bad design decisions, which can be a challenge. Though usually events sort of correspond to things from the problem domain, so they tend to be fairly static. And also with any system, you have to, message-oriented system, you have to deal with the possibility of duplicate events, which can be a challenge. But the systems I've been building, every event that gets published has a monotonically increasing time-based IDs, so you can easily detect duplicates. And then also because we've now got eventual consistency, your application might actually have to deal with that. You know, you could actually update an entity and then go look in a view that's sort of a denormalized view generated off the events, and that because of a replication lag, that view might not have been updated yet, and so, you know, you've got your code has to be slightly more complex to deal with that. And then there's also the limitation that the event store is all about retrieving events and updating events by primary key. There's no support for joins, which is a whole other talk about an architectural pattern called command query responsibility segregation, which is a way of solving that. Anyway, so that's sort of event sourcing and kind of why it matters and what the benefits are and what some of the drawbacks. And I kind of wanted to actually look at some code. So you think about, you know, building a domain model. you know, some things have stayed the same. So you've still got the familiar building blocks, and your domain model is still built out of entities, value objects. There's a concept of aggregates. In fact, in this system, the notion of aggregates become a lot more important. You break up your domain model into aggregates, and each transaction only actually updates one aggregate at a time, and then publishes events, which can then trigger the update of other aggregates. The actual nature of the aggregates change. So rather than a mutable kind of classical sort of domain model, object-oriented domain model, where you've got debit, you know, methods that mutate the state, we now go into sort of a functional, immutable, event-centric approach. So instead of a debit method that changes the state of an object, we now have a debit command and a debit account debited event. And the actual each aggregate has two methods: process command, which takes a command, gives you back a sequence of state-changing events, and then an apply event method that actually takes an event and gives you back a new object, a new entity that has been updated to reflect that state change. So it's sort of, you know, there's kind of a one-to-one mapping, but it's kind of quite different. You know, one of the challenges you have is designing domain events, right? You know, the naming, they tend to, you know, they sort of have to be in past tense because they're representing things that have happened. Hopefully in your domain you can have specific names that mean like debited and credited, as opposed to something vague like, oh, I've just updated this domain object. You know, they have attributes that you know, I mentioned there's an ID that's basically a time-based UUID, plus any attributes from the command that are necessary to then update the state. And then there's also the idea of event enrichment, where not only do you just have the attributes that are necessary to update the state, but you also throw in some extra data that is useful to the consumers elsewhere in the system of that event. So instead of just, when you say you add a product to a shopping cart, just having the product ID, you'd actually have the product info, because the downstream consumers actually need the product info. So rather than requiring them to go back and get it, that information is packed in the event. And there's a kind of a whole bunch of issues around balance. Like, you don't want to make the events too fat, so to speak, but you don't want to make them too skinny that the consumers have a lot more work to do. So you've got to kind of have balance. So kind of have slightly two different ways of representing domain objects. One of them is kind of a hybrid sort of OO plus FP approach, where I've got a couple of traits, aggregate that has the apply event method that returns a partial function from event to updated aggregate, and then the command processing trait that has a process command method that returns a partial function from command to a sequence of events. So these are actually base traits. So the actual aggregates have to implement these traits. So here's an example of the account. So, you know, so account implements command processing aggregate, blah, blah, blah. And you can see like there's a process command method that's using Scala pattern matching to map each incoming command to a sequence of events. You know, and there's an overdraft check in there, as you'd expect. And then there's the apply event method that's a partial function that's doing pattern matching from event and to updated domain object. Once again, because of, you know, it's a case class, and so you can just copy it and modify the attributes that you want. Though interestingly, you know, there's scope here for lenses if you want to go fancy and you know, hardcore if you want. Some of the other examples I have do that. The underlying event store, you know, has like save, update, find methods, you know, with kind of type parameters, and generally looks like someone sat on the keyboard. you know, there's another interesting, that you actually do not have to interact with the event store directly. So I've got a couple of sort of simple DSLs. So here's the account service DSL. So here's the account open account method. And the DSL just says, so go create a new entity of type account and have it process the open account command. And under the covers, it's actually instantiating an account, you know, calling the default constructor, processing the command, applying the events to update it, and then persisting the events in the event store. So all of that boilerplate's hidden just by using this kind of nice little DSL. And likewise, the code that subscribes to events being generated by other aggregates also uses a DSL as well. So it's like handler for this kind of event. In this case, it's updating an existing entity whose ID is this by processing that command. And so under the covers, it's loading the aggregate from the event store, processing the command, applying the events, and then persisting the new events back into the event store. And that's all hidden with the behind the less than equals thing. So that, you know, that I found that's actually worked quite nice. And then recently, I've been working on a more sort of pure functional approach. And that actually has similar kinds of traits. So like aggregate, which has got apply event. And you see apply events is doing a fold over the event stream. And then there's the command processor with the process command. But rather than the actual domain entities or domain aggregates actually implementing these interfaces, they actually play the role of, they actually function as implicits. Or kind of like multi-parameter type classes, which is actually a concept in Haskell, but not so much in Scala. So the code ends up being, this is a little hard to read, but here's the actual domain class, the money transfer, and it's just a straightforward case class with absolutely no behavior, just the state. And then there's an implicit object, a money transfer aggregate that implements those two interfaces that has process command and apply command. And so there's this sort of the standard functional separation of state and behavior, which seems to be popular within the functional programming community. So then, you know, here are the events. So they all inherit, like they all extend a money transfer event. Here are the commands and so on. And then the actual event store is a little, the signatures, well, the method names are the same, but the signatures are different because, because it needs to take these, the implicit, the aggregate that tells it how to actually instantiate an aggregate and how to actually apply events. And I sort of find writing this kind of code a little painful, like trying to actually eliminate the sort of how to avoid having to specify all of the type parameters. And I found just by passing in the class object, all the type inferencing kind of figured out what T is and figured out what EV is without you ever actually having to write it out. But I was sort of playing around with this for a few hours. Anyway, so hopefully that's given you sort of a flavor of, you know, kind of a different way of writing sort of domain models of functional, that are both functional but also event-centric. And, you know, I like Scala for this, right? You know, case classes are this great thing that just eliminate a lot of sort of boilerplate code. Pattern matching is like super useful. And then, you know, just the fact that recreating state from a sequence of events is really just a fold, you know, that's really quite nice as well. So anyway, so that's my talk. I had no idea how long I was meant to speak for, but that's all I have to say. So thank you. Yeah.
How do you address the bottleneck of truth inference between incoming commands and derived events.
Well, say that again, the bottleneck?
Yeah, so by bottleneck, I mean if you want to be able to process a set of commands or a domain of commands and emit events from that, it takes some computation to validate that you can parse a command and then validate that it makes sense in context. And so all of that consumes time before events can be emitted. And so in my experience, it tends to result in kind of a backlog of commands as they come in that you can only process at a certain rate because they need to happen in order, for example.
Yeah, so sort of the question was, well, kind of all of this processing of a command takes time, and so can create a backlog and delay when events get published. Is that sort of roughly it? I don't know. I guess I haven't really seen that problem. In a way, I view the processing of commands in this architecture to not really be any different from processing requests in a more standard architecture. And I mean, the one way you could end up with bottlenecks is if you end up with a whole bunch of concurrent requests for the same entity, and then you get a lot of optimistic locking failures and retries. But apart from that, everything, there's great scope for request level parallelism, right? The event store is super scalable because it's very shardable. And then the actual app side of it is also very scalable as well.
So a concrete example I could sort of make up is if you wanted to be able to scale out where do you, one approach is to shard, and in that case you're sort of, I guess, creating different aggregates that maybe don't step on each other's toes. But what if a specific shard itself would benefit from scaling out? Is there not a problem in, for example, many users wanting to access that, and so you want to spread it out to different machines? But if it's all part of the same aggregate, you still start to run into
Oh, yeah, I mean, so sort of the comment was, well, what's the granularity of the aggregates? And I view it as things like user, account, shopping cart, product, order. So very kind of somewhat fine-grained. And yeah, if you go read the literature, they will talk about, the interesting read is Implementing Domain-Driven Design book, the kind of the more practical guide to DDD than the blue book. It's sort of the red and black one. And one of the examples they have in there is like the initial version of some domain model had some giant aggregate that resulted in like massive concurrency problems, and it's like, oh, well, we just need to have finer grain aggregates, and the concurrency issues go away. Any other questions? Yeah.
If you need to maintain some sort of transactional semantics between different aggregates, like I can imagine that if you had two accounts and you wanted to do a balance transfer, that might be a single event that mentions both accounts. Is that how you do that?
Oh yeah, so if you do need to kind of maintain sort of transactional integrity. That's actually like I have an example of exactly that in another talk, which you can see online, but briefly, right? So it's kind of like you create a money transfer object that says need to transfer money from account A to account B, or $10. That published, so that's one transaction. That publishes an event. Then the account is subscribing to the money transfer created event and goes, oh, well, I'm going to go debit this account, which generates an account debited event, which then triggers the update of the money transfer to say that the debit part happened, which publishes another event that triggers the credit, which then triggers the update of the money transfer to say that the transaction is complete. So there's a lot of, it's a sort of a multi-step process with events bouncing back and forth.
That's a very interesting solution, one I haven't thought of. It does seem a little risky because it suggests that, or it allows for transfers that are not, transactions that are not part of the money transfer. That is, you no longer get sort of a robust requirement that only transfers happen via your money transfer object, because any increase in balance is going to be accepted by that account.
Well, yeah, so you're sort of saying it's sort of less, well, sort of the enforcement is looser. Yeah. I mean, I suppose it is. I mean, the one thing that troubles me about it is, right, you can't look at the money transfer workflow because it actually ends up being split between the money transfer class that's subscribing to events that are being published by accounts, and then there's the accounts that are subscribing to events being published by money transfer. So it's kind of like it's spread around, but it seems workable. Yeah.
You could solve that by passing around some sort of contextual ID, saying like a transaction ID, for instance.
Oh, yeah, it's funny you should say that, because yeah, the actual, so a transaction, or a money transfer has a transaction, has a primary key, so that's the transaction ID. And then when a debit happens, or credit in an account, it's because of that transaction ID. So there is this traceability. Thank you. Well, thanks. And you can, find me online somewhere.